Good morning, students. Today you will learn about how to find out the solution for the numerical problems. Book back problems, page number 89. What is the heat in joules required to raise the temperature of 25 grams of water from 0 degrees Celsius to 100 degrees Celsius? What is the heat in calories? Specific heat of water is given 4.18 joules per gram degree Celsius. What is heat? The sum of the kinetic and potential energy is called the internal energy. This internal energy when flows out is called heat energy. This energy is more in hot substances and less in cold substances and always flows from hot substances to cold substances. Write the given data. Mass of water m is given 25 grams. Then initial temperature of water Ti is equal to 0 degrees Celsius. Then final temperature Tf is equal to 100 degrees Celsius. Rise from 0 to 100 degrees Celsius. So 0 is the initial temperature, 100 degrees Celsius is the final temperature. The change in temperature del T is equal to Tf minus Ti. Final temperature minus initial temperature. So final temperature is 100 degrees Celsius. Initial temperature is 0 degrees Celsius. So del T is equal to 100 degrees Celsius minus 0 degrees Celsius. Finally, change in temperature del T is equal to 100 degrees Celsius. Then next given data, specific heat capacity of water C is equal to 4.18 joules per gram degree Celsius. What is specific heat capacity? Specific heat capacity of a substance is defined as the amount of heat required to raise the temperature of 1 kg of the substance by 1 degree Celsius or 1 Kelvin. SI unit of specific heat capacity is joule kilogram power minus 1 Kelvin power minus 1. C is equal to Q by M into delta T. We need Q, so Q is equal to M into C into delta T. Here M is mass of the body, C is specific heat capacity, del T is change in temperature of the body. So next, to find heat required Q in joules format and heat required Q in calories also. What is the formula? Heat required Q is equal to M into C into delta T. M mass of the body, C specific heat capacity, del T change in temperature. Solution heat required Q is equal to M into C into delta T. Substitute the M value, mass of the substance 25 grams into C specific heat capacity of water C is equal to 4.18. So substitute here C is equal to 4.18 joule per gram degree Celsius into delta T change in temperature 100 degree Celsius. So 25 into 4.18 into 100. So 4.18 into 100 is equal to 418. So heat required Q is equal to 25 into 408 10,450. So heat required Q is equal to 10,450 joules. We calculated in calories format means we know the formula 1 calorie is equal to 4.18 joules. SI unit of heat energy is joule. Other two commonly used units are calorie, kilocalorie. What is calorie? We know 1 calorie is defined as the amount of heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius. The relation between calorie and joule is 1 calorie is equal to 4.18 joules. Or we interchange the left and right side means 4.18 joules is equal to 1 calorie. So 1 joules equal to means that 4.18 go to opposite side means it is in the denominator. So 1 joules equal to 1 by 4.18 calories. We need 10,450 joules. So 10,450 joules is equal to 10,450 into 1 joule. 1 joule is equal to 1 by 4.18 calories. So here 10,450 joules is equal to 10,450 divided by 4.18 in calories. So we multiple 100 on both sides means we get 10,45,000 divided by 418 calories. We can cancel the numerator and denominator with 2 means we get 5,22,500 divided by 209. So the above answer divided by 11th table means we get 47,500 divided by 19 calories. 47,500 and 19 both are divided by 19th table means so 2,500 is the answer. So finally 10,450 joules is equal to 2,500 calories. So what is the result? The required heat Q is equal to 10,450 joules, or in calories means it is equal to 2,500 calories. Now we move to the second problem. What could be the final temperature of a mixture of 100 gram of water at 90 degrees Celsius and 600 gram of water at 20 degrees Celsius? So we combine the 100 gram of water and 600 gram of water means what is the final temperature. So first write the given data. Mass of the water M1 is equal to 100 gram. So we know 1000 gram is equal to 1 kilogram. So 100 gram equal to 0.1. That means 100 divided by 1000 kilograms. 100 by 1000 means we get 0.1 kilogram. We know specific heat capacity of water C is equal to 4186 joules. So temperature of 100 gram of water is 90 degrees Celsius. Mass of water M2 is equal to 600 gram. M2 is equal to 0.6 kilogram. So 600 gram is equal to 600 divided by 1000 kilogram. So finally we get 0.6 kilogram. So temperature of the 600 gram of water is equal to 20 degrees Celsius. To find final temperature of a mixture. So 100 gram of water at 90 degrees Celsius, 600 gram of water at 20 degrees Celsius. Both are mixed means what is the final temperature. So final temperature of a mixture TF. We know the formula. Heat lost by water is equal to heat gained by cold water. So formula for heat M into C into delta T. So here we used M1 into C into theta 1. M mass of a substance, C specific heat capacity, theta 1 is change in temperature. So here heat lost by water is equal to heat gained by cold water. So substitute the both values. M1 mass of the substance 0.1 kg into 4186 into change in temperature 90 minus TF, that means final temperature. So 90 minus final temperature is equal to mass of the water M2. M2 is equal to 0.6 into 4186 into final temperature minus 20. So both side we cancel the 4186 means balance 0.1 into 90 minus final temperature TF is equal to 0.6 into TF minus 20. So 0.1 multiple with the 90 means 0.1 into 90, it is equal to 9 minus 0.1 into TF, that is equal to 0.1 TF. So 9 minus 0.1 TF is equal to 0.6 TF minus 12. So 0.6 into 20 means we get 120, then one digit cancel, last digit cancel 0, so 12 balance. So now we get 9 minus 0.1 TF is equal to 0.6 TF minus 12. That minus 0.1 TF go to opposite side means plus. So the minus term go to opposite side means plus. So minus 12 comes to this side means plus 12. So 0.6 TF plus 0.1 TF is equal to 9 plus 12. Now 0.6 plus 0.1 is equal to 0.7. 9 plus 2 is equal to 21. Now we get 0.7 TF is equal to 21. We need TF, final temperature of the mixer, is equal to 21 divided by 0.1. So multiple 10 on both sides means we get final temperature is equal to 210 by 7. So both also cancel with 7th table means, so here 3 sevens are 21, then 0, 30. So 37s are 210. So final temperature of mixer TF is equal to 30 degrees Celsius. Now the third problem, how much heat energy is required to change 2 kg of ice at 0 degrees Celsius into water at 20 degrees Celsius. Specific latent heat of fusion of water is given 3,34,000 joules per kilogram, and specific heat capacity of water is given 4200 joule kg power minus 1 k power minus 1. So first write the given data. Mass of the ice m is given, that is equal to 2 kg. Then initial temperature 0 degree to 20 degrees Celsius. So here initial temperature is 0, final temperature is 20. So initial temperature Ti is equal to 0 degrees Celsius. So we know the formula. Kelvin is equal to C plus 273.15. So here Ti is equal to 0 plus 273.15 Kelvin. Initial temperature Ti is equal to 273.15 Kelvin. Then final temperature TF is equal to 20 degrees Celsius. So Celsius converted into Kelvin means it is add with 273.15. So 20 plus 273.15, it is equal to 293.15 Kelvin. What is the change in temperature? Change in temperature formula, del T is equal to TF, final temperature minus initial temperature. So 293.15 Kelvin minus 273.15 Kelvin. So change in temperature del T is equal to 20 Kelvin. Then other two given data, specific latent heat of fusion of water L is equal to 3,34,000 joules per kilogram. What is specific latent heat? Specific latent heat is the amount of heat energy absorbed or liberated by unit mass of a substance during change of state without causing any change in temperature. The SI unit of specific latent heat is joule per kilogram. Specific heat capacity of water C is equal to 4200 joule kilogram power minus 1 Kelvin power minus 1. So we want to calculate heat energy required. What is the formula to calculate the heat energy? Heat energy required, Q is equal to M into C into del T plus M into L. So we combine the two values means we get the total energy. So heat energy required, Q is equal to M into C into del T plus M into L. Substitute the value, mass of the ice 2 kg, C 4200, change in temperature 20 Kelvin. Okay, plus M into L. So mass of the ice 2, then L, specific latent heat of fusion of water. is equal to 3,34,000. So 2 into 20 means 40. So 40 into 4,200 joules plus 2 into 3,34,000 is equal to 6,68,000. So now 40 into 4,200 is equal to 1,68,000 joules plus 6,68,000 joules. We can add the two values means finally we get heat energy required Q is equal to 8,36,000 joules. So result heat energy required Q is equal to 8,36,000 joules. Thank you students.